Yakub Zabral, the founder of Zeta Alpha, who'll be talking and revealing how new AI search technology can prevent AI and data science teams from going crazy. Now, I'm delighted to introduce our third session, a presentation looking at how we deal with unstructured data, a problem many companies are grappling with. Debjyoti has developed machine learning algorithms for Bing ads, Microsoft R&D, and worked as a decision scientist at HSBC Credit Risk team. He is now a data scientist at Amazon, and we are delighted to welcome him. Welcome, Debjyoti. I hope I pronounced your name correctly there.
Yeah. My name is Debjyoti. Yeah, you are perfect in pronouncing. Okay, I will share my presentation. Is it visible? Is my screen visible? Okay, I think it is visible. Yeah. Okay. Thank you for the introduction. So today I'll be talking about something which is called finding pattern in unstructured data. So to the typo here, finding individual in unstructured. So first I would like to define what's a structured data and what's unstructured data and what's a semi-structured data. So structured data is something which we can keep in our database. So suppose like if you think about SQL databases, these are those which can retrieve by queries. These are very well maintained. You have column names, you have keys to join on. So these are what we call structured data. What we find is that in the world of data and business driven by data, only 5 to 10% of the data that we see is only this kind of structured data. So what's the other kind of data? It's like semi-structured data. So what is semi-structured data? So instead of SQL tables, you can have CSV file or XML file, which are still information or data which are still have a form. You can read a comma separated file very easily and then transfer it to SQL. So transforming semi-structured data to structured data is quite easy. Often we don't do it in the full we don't do it upfront because we might need some more data collection when we need some more pre-processing before putting it as a table into SQL or some structured database. But the interest, like it is another 5 or 10% of like the data. So structured data and semi-structured data is like around 20% of the data. So that makes us, question what is the other form of data, and that's unstructured data. What is unstructured data? There is no structure to it. There is no particular pattern to it. It is not readable through a single or 5-10 lines of code. You might need serious amount of effort in reading, processing this data. But being 80% of the data, it makes it challenging to gather information from it, as well as this is kind of something which we look forward to do to get more insight. And from unstructured data, we actually move to a semi-structured data, and then we actually move to a structured data. So over time, we move from this unstructured data to the structured data by rigorous practice of different kinds of techniques which I'll be talking about. So satellite images, scientific data like atmospheric data, all these things are unstructured data. So social media data is one of the important example of unstructured data. Then mobile data, website content, like if you look at Facebook, YouTube, all these are unstructured data. So let's look at so it's 80% of it, and unstructured data is everywhere. If you want to add more value to your business, structured data are very sparse to start with, because at the very start, and I will talk about some of the examples that I have encountered in my personal projects, where kind of I have seen that there can be a lot of value addition that can be done from this unstructured data. So basically, once you have defined unstructured data, so I will talk about how to recognize pattern in unstructured data. So there can be two types. There can be many types of unstructured data, but I will be focusing the discussion to two types. One is text and one is images. Video or multimedia being a text image form, we can always talk about a combination of text and images, which is a multimedia font. Text and video consist of a large chunk of this, unstructured data, and the whole point is like how we can use this, unstructured data to your, day-to-day, business to add value to your business. So suppose like you are a hotel, or you are a director of a movie, and you have directed a movie or produced a movie, or you are an actor in a movie, or you have some products on the internet. So what is the thing that you look for is the reviews, because the reviews helps you to know how your product is doing, as well as to get feedback on the product. So you want to connect with your customer. So I'll talk about chatbot technologies, which are basically media of connecting to it, and how answer data is changing those technologies. So you have to gather, if you want to gather any information. So suppose like, for example, if you want to know about any business today, what we do is go to Google, we type that website, find that website, go to LinkedIn, find that website, or go to some startup site and find the website. We want to find the person, go to Twitter or go to Facebook or Instagram. You'll find enough information about them. So then like text to speech, right? I mean, suppose like I'm talking right now in the video, so there can be technology which can generate transcript based on this, and those are like basically unstructured data, because like it is generating from any video. Then a human conversation via SMS, via WhatsApp, all these things are unstructured data, because human language is so much diverse in that sense. We often tend to use 2-3 languages at a time, which is very difficult for to structure either at the very start. So sentiment analysis, I've worked quite a lot on sentiment analysis as one of my research projects. Aspect-based sentiment analysis. Like suppose like I am a restaurant and I'm talking about like some customers talking about, oh, the food was good, but yeah, the AC or the lighting was not good, the ambience was not good. So I as a restaurant owner would be much more interested in finding out what went wrong for the customer, what went right for it. So that's one of the way where we need to sparse structure, sentiment analysis. So we have to go to some site where people are posting reviews. We have to parse those reviews and to do sentiment analysis for them, because for those products, so that we can improve our service. Chatbot modules. So I talk about chatbot modules in more details, but right now how most of the chatbot works is that you give a list of question answers and the chatbot respond to that. But if you want to make the chatbot more interactive, if you want to slowly disengage any human in the loop, if you want to make the chatbot respond to question that it doesn't know, further the chatbot has to go out and learn to Google. So that I'll define that I am working on a chatbot which actually is learning to Google on itself, but it can go very wrong in different aspects, and I'll talk about that. So that's kind of a chatbot. And again, from the image side, like you might want to do OCR. So when I was traveling, I find it, the Google Translator has a feature of translating from image to, so I was in Europe last year, and I didn't know German, so I had to translate a lot from using Google Translate. As well as when I was in different parts of the world, like I had to use Google Translate because I didn't know the language, and it's an amazing technology in that sense. And memes are a form of communication. So right now there's a challenge which kind of try to classify memes, which is kind of interesting, because we are now trying to go to multimedia data and trying to find out what's the content in that, because a lot of information is in that. So security-based technology. So we are working on a security-based technology, which is another of my personal projects, which we are trying to find security-based system based on cameras or hidden cameras or kind of security cameras. So to talk about machine learning on unstructured data, first of all, like when you decide to go for unstructured data, you have to have a base problem. So I will define some base problem and walk through some case studies. So if it's a classification problem, you have to define whether you have labels or not. If you don't have labels, then probably you have to question yourself that whether I need labels. For example, if I want to classify my a customer into high return customer, low return customer, then I need a label for those things. Then how to find the right data. So once you define the problem, then you have to go and find the right data. To get the right data, so I talk about different scenarios where how we decide to get the right data. So now from the right data, you have to sit with your business, people who have the idea, who knows how to, So for building a chatbot, you have to sit with the customer agent who actually answers right now and walk through how she does it or how he does it, and then get the chatbot do the same thing. So it's about so it has to be defined. And second, then we have to go and find the right data. Unless you find the right data, the machine can't do any magic for you. So once you gather the data, so if it is structured data, if you have CSV, you can just move it to a structured data. If it's not a structured data, which is most of the time, we have to do a lot of steps, and we will define three steps. One is analyze, build machine learning model, and evaluate. These are the three things which we have to keep in mind. So how do I know that I have the right data? This is very, very important. So for this, you have to sit down with the people who know the business sense. So if I am building a model for a bank loan, a bank, you have to sit with a relationship manager who gives out loans and understand what the relationship manager does. What are the criteria that it looks for? Your data, if you have a chunk of data, you can't just start from anywhere. You have to know the starting point. So relationship manager will look for cues that a customer has a good history or it has good deposit. This kind of very features which you can start straight away as a base feature, and then you can build models by different kinds of other techniques that I will discuss. So text analytics, I'll very shortly talk about text analytics. So to extract a lot of this text from the internet, you need something called Beautiful Soup. So Python has a very good library called Beautiful Soup, which can parse HTML for you. Then you have to do all kinds of text analytics. For image, you have to do a different kind of analytics. So this is a word cloud. So you can do different kinds of LDA, parts of space. You can put word histogram. This kind of analytics you can do, and you can get very good insights from the data. For images, you can do a distribution of different grayscale. You can pass through different kind of wavelet transform. So this is one ImageNet model. So it is a large neural network model which is trained on millions of images. And what you can do, you can take whatever image you have, you can pass it through that. You will get a base point. You can get some some feature representation of that, and you can analyze that. So this is another way. So there are basic transform like HOG. This is called a histogram of oriented gradient. So you can get gradients of the images. These are good ways to find whether your data is right, whether it's giving some idea about the problem you're going to solve. Image analytics also consists of all these other exploited data analytics. You can do LD on images. You can do all kinds of frequency. You can convert images to text, and you can do different kinds of other analytics. So another important point to start with is that maybe you are working on a problem where a lot of people have always spent a lot of resources. For example, there is a model which is called GLOVE or word to wake, which is basically text model trained on large chunk of text like Wikipedia. And what can be done is like you can train your model on that. Those models are already available open source. You can start there. So you can use those models to start with. So for example, when I was building the chatbot, the initial vocabulary of the chatbot. So how does a chatbot know that a word like man is similar to a boy? So for example, to know that, I have to give some information to the chatbot. So the way I gave it is using a model called word to wake, which was trained on Wikipedia data. Or I used a model called GLOVE, which has 6 billion tokens. So 6 billion tokens is the number of words on which it is being trained on. So it is a huge model. So it will cover a lot of the text that you are already using. You can retrain the model for your purpose. So that's called transfer learning. So I talked about ImageNet. That's already image classification model trained on millions of images. What you can do, you can start there, and you can build your own image model by borrowing the learning from that model via technical transfer learning. The second problem is, so suppose you are at a problem where, because you have unstructured data, you don't have labels for that. So what you can do, you can take help of your friends or colleagues and label a bit of it, and then use the technique called label propagation. It's a very well-known analogy or term in social media, where, for example, as a social media, if I see a post and I like it, it is most probably going to be shown to my friends page or people who follows me. So that means that if something is similar to something, then probably that is much likely to be of the same class. So if you have a set of already good ground truth on some samples of data, you can always propagate it to other samples. So these are two techniques with which you can generate more labels, and you can enrich your models or enrich your feature. And let's now talk about some case studies, some of my personal projects. So I'm currently building a chatbot for one of my friends, and the problem is the chatbot has to learn on its own. So there are lots of terms that So they want to call different API and then gather those information and try to classify and try to answer. And further, the chatbot has to first get the human response, human question, and classify and then find out which API to question and then come back and answer it. So for that, the chatbot might need to learn new terms. So what we are trying to do is we are trying to find out ways for which chatbot will learn different concepts. Also, there can be problems where so right now there is a human in the loop. So if the chatbot doesn't know, it flags it, and the human tries to make some sample data for the chatbot so that it learns it. So it learns every day. But going forward, it will try to it will know how to Google on its own, and also it will try to build its own knowledge base. And also the knowledge base should be readable to a human because of all the explainability problems that we see today. And the second thing is that we have to make sure the chatbot doesn't learn anything abusive from the internet, because the internet is a huge circus going on. So it is very difficult for the chatbot to filter out which is relevant, not relevant information. So we have to build that thing as well in the chatbot. And also the chatbot should be able to so it is kind of also trying to figure out how the company jargon is different from the actual jargon in the real world data. For example, if a bank if someone is talking about a bank, then it's not about the a river bank. It's a bank about a bank where you keep your money, right? So those kind of these ambiguities it has to go through. So another thing is the face recognition for security, and the thing that we are working on is that how can you train your model to know the person who are near and dear to you or who visits your house, and how can you flag that when somebody unknown try to sneak in or try to move around? It's very difficult to know, and it can preempt a lot of harm that can cause to you, or it can do a lot of those stuff. So we are building this kind of technologies which will protect your home from a lot of security issues or your offices. But then there is a very interesting project where a client wanted, one of my friends company who were trying to build, who basically works with different kinds of people, different kinds of clients. So they target different kinds of clients. So they call up the phone and sell their service to different kinds of clients. And now the problem is that there are only 100,000 clients, and you can't engage your person or your marketing people to engage with all of them. So you have to prioritize. So how can it prioritize? So probably what they want is that can a machine look at the website of these companies and figure out for the customer agent or the marketing manager to prioritize which customers to go after that. So they have a return on each of the clients, that which clients are high returning clients, and based on that they are labeling the data. And then based on the website, the problem is that a website can be a huge noisy data set. So people put all sort of stuff in the website to filter from the stuff. So we are building our own in-house techniques to filter out which are the words which are relevant. So none of the things which available right now in NLP caters to that, because it's very unique need where some words might be very much related to high paying client versus some words which might not be, and it's not very intuitive. So we have talked with the expert, we have got the basic so we have get the basic features, and now we are building the chatbot model. We are building the targeting model, and we have kind of build it. So we call it Transfer Learn Plus. We are using the base model as love model, and we are refining our model, and then we are denoting our feature, and we are incorporating expert insight, and we are building the final prediction model which will rank the client. Okay.
I'm so sorry to interrupt you there, Debjyoti. I'm so sorry to interrupt you. Sure. We are sadly running over time at the moment, but we do have a Q&A session. So I'd love for you to be able to wrap up your sort of comments with the rest of our audience. We would love to continue the conversation with you in the Q&A session. Thank you so much. If you've got questions for Debjyoti, as I said, please do follow him into the networking lounge and speaker Q&A room. The link is going to be dropped into the chat now by our team. So please do follow him through. Debjyoti is going to be able to continue with his camera and audio on. So if you'd like to type your questions through for the session chat, he'll be able to read them out and directly answer to you all. Please do try some one-to-one networking via the networking tab, and also add yourself to